welcome the one and only John Romero.
Is this close enough? Yeah. Do I need to speak through this? Well, thank you all very much for having me here. I know a lot of you like shooters, I think. Yeah? All right, well, so I'm doing a talk here about id Software's early days and in the lessons that we learned while we were making a lot of games. How many of you are programmers here? Yeah. Awesome. Well, if you're not a programmer, it's a really fun story anyway. But the reason why I mentioned that is that in this presentation I have these core programming principles that we developed while we were making our games in id Software, and it helped us make a lot of games very quickly. And I'm not sure how many of you knew how many games we made, but you'll find out after I talk about it. So anyway, welcome everybody. I'm John Romero, co-founder of id Software. It was actually my fourth startup company. I'm going to be taking you on a journey back to the beginning of id Software. And are you ready to be entertained? Yeah. All right, I realize that some of what I'm going to say may sound insane, but we were in our 20s. And we had no idea that when we started id Software that there were any limits. So I don't have any music or sound effects, but there's probably some idyllic music here. I grew up in a wonderful small town in Northern California named Rockland, California, and there were only 6,000 people in that town back then, back in the 70s. Back then, in the 70s, I was massively addicted to spending loads of time in dark arcades and playing all the games there and getting really, really good at those games. In 1979, before anyone had a computer at home, including me, I went to the local college when I was 11. It's not normal. I started learning BASIC from the college students. I went up to them and I just started asking what the words were on their screen. And they were telling me. So I was writing all that down on paper and started experimenting with all this BASIC on the HP 9000 mainframe that was in the next room. So to keep me at home, my parents got an Apple II computer, and I was done going outside after that. So I spent all my time programming games on that computer. I remember what it was like going outside too. Before that year. A few years and 20 Apple II games later, all in BASIC, I finally learned 6502 assembly language, which was the language that all fast arcade games were written in. Then I could really make 80s games like these. Well, not quite arcade games, but home computer games, and that's how cool they looked back then, on the Apple II. So let's just say the Apple II was my personal home arcade, as well as, like 1 million other Apple owners back then. So when I was a sophomore in high school, I did some programming for the Air Force when I was 15 years old. We lived in England at that time, and my stepfather worked for the Air Force. So in order to get into high school programming class, I showed the teacher that I could program in 6502 assembly, and I ended up at the aggressors squadron the next day, which is basically Russian counter-tactical planning. And I was literally coding in a vault, like a bank vault. So because I was a kid, they gave me false data, so it wasn't the actual real data. But I can't tell you what I was programming because that's classified. After high school, I kept making games, and by 1987, I was working at Origin Systems, which was my dream job. The first job I had there was porting 2400 AD from the Apple II to the Commodore 64. And by this time, I had made 74 games and 3 previous startup companies, which was Capital Ideas Software, my first company, Inside Out Software, where I ported Might and Magic 2 to the Commodore 64, It was also one of the very first companies to do a game based on the Alien license, the movie Alien, and Ideas from the Deep. And by that point, I was 21 years old. So I went to work at a company named SoftDisk at the start of 1989, and I learned how to program a DOS PC there. And I, at that point, made a small game or a utility every single month for a whole year, basically shipping every month. Then I got tired of that, and I created a game product called Gamer's Edge at SoftDisk, where I could actually spend 2 months making a game. And I had to hire a team of game programmers, for the first time a team. So I hired John Carmack and Adrian Carmack, yep, not related, into my department for programming and art. And then Tom Hall came in at night to help us out since he was already at SoftDisk, and he loved making games. So this was the first time that any of us had worked with another person on a game after making games individually for 10 years each. So it was pretty amazing. While creating our first game together, which was called Slordax, John Carmack discovered this smooth scrolling trick on the PC. Tom Hall and John stayed up until 5 a.m. making a demo called Dangerous Dave and Copyright Infringement. And the next day I saw the disk on my desk and popped on the computer there and I ran it. And I watched the screen scroll smoothly, pixel by pixel, and it was like a massive eureka moment for me. It was like a bolt of lightning. It was unbelievable, and I'll elaborate why it was unbelievable in a moment. But id Software was born that instant on September 20th of 1990. So one thing led to another, and we spent a week putting together a demo of Super Mario 3 for Nintendo, which they really liked, but they decided not to publish this demo because they decided to only publish their games on the NES platform, the Nintendo platform back then, which was a smart move at the time. But no problem, we used the tech for a different game, which was the Commander Keen trilogy. So, why would a side-scroller be a huge hit on the PC in 1990? Well, because no games on the PC could scroll horizontally smoothly, pixel by pixel. The PC had been out since August of 1981, but in 9 years, no one had figured out how to make the screen scroll smoothly per pixel until that Dangerous Dave and Copyright Infringement demo, which led to Commander Keen. Which is pretty amazing. Does anybody remember Duke Nukem down there in the bottom left corner? Yeah? So the reason why Duke Nukem actually moved on the screen at a frame rate was because Todd Pokel didn't know how to program EG graphics fast enough, so I called him up on the phone and told him how to do it, so he could actually make Duke Nukem. So the Commander Keen trilogy provided the start of the company, and we made these 3 games in 3 months, from September 20th to December 14th of 1990, and that's the day that we released Commander Keen. So it was a massive hit for us, and it was so popular that people cosplayed as Keen for years at events. They still do. And the game pioneered the creation of game engines. So we designed the game as an engine that operated on different data for different games. It was the only way to get the trilogy done so quickly. In fact, in 1991, when we were working on Keen 4, we started licensing the engine for the first time. It was the beginning of the modern engine licensing business. So development on our games went very smoothly and quickly because we stuck to some core principles that are important even today. So through this talk, I'm going to highlight some of our core principles. I'd like to highlight something else right now, namely this photo. Has anybody seen this picture before? Nope? All right. One person has seen it. It's a picture of the lake house in Shreveport, Louisiana that we started at Software. And so the funny thing is that people have asked me for years when they come across this picture, what is in this picture? Like, what is all that stuff? So I decided, all right, I'll identify things that are in this picture. Anybody that's programming games at home, take note. Your room might look like this. So this is John and me in early September of 1990. We were working on the Super Mario 3 demo that we planned on sending to Nintendo. we both worked on this huge D&D table that John had. He brought it down from Kansas City when he moved to Louisiana. We used to play D&D on the weekends, and those sessions led to ideas for our future games, Doom and Quake. This is John and me, and Tom took the photo. Tom Hall took the photo. We were working on the Super Mario 3 demo. These computers that we worked on were brought home from work on the weekends. We didn't have PCs. So this pic was taken on a Saturday or a Sunday. On top of the monitor is one of those old Intel reflective astronaut photos, if anyone remembers that whole marketing campaign. To my left is my notepad, which was a task list of bugs to fix. And you can see, like, there's the NES with Super Mario 3 running right in the center of us, so you can watch the movement. This is our high-level task list on a whiteboard, and everything on it that we needed to finish the demo, to finish it. And this is Tom Hall's area. He's on this other table. He was doing all the graphics for the demo, so he recorded Mario running on the VHS tape, and he played it back, and he paused the action so he could duplicate the tiles exactly in Deluxe Paint 2, which used to be the Photoshop of the game industry back in the 90s. So the TV set had 13 channels, a 13-channel selector, which was olden days to everyone here, and it was connected by an RF modulator, so there was no HDMI back then. So its software was formally founded on February 1st of 1991. We made 12 games that year. Shadow Knights, Dangerous State, The Haunted Mansion, Rescue Rover, Hover Tank 1, Rescue Rover 2, Keen Dreams, blah, blah, blah. Made a lot of games. We took actually 2 months per game, but we made 2 games at a time. And so this was due to us having 10 years of intensive game development experience prior, but it was also due to our first principal at that time. So no prototypes. Just make the game. Polish as you go. Don't depend on polish happening later. This thing's coming out in 2 months. Maintain constantly shippable code. This is how we made so many games so quickly. We had the whole game design in our heads. It was just 4 of us, so it was really easy for all of us to understand what we were making. We just needed to quantify what needed to be done, and we went about working on it until the game was finished. So there weren't any prototypes, we just made them. Obviously, with bigger teams, that's not going to happen nowadays. But back then, with small, and there are small games today in mobile that one person could make, or even Minecraft. But yeah, no prototypes back then. We had to get these things done fast. So time for a quick story. One day, it rained really hard, and Cross Lake in Shreveport, it rose and it was flooding everywhere, and I needed to get to work. Like, we were working furiously getting our games done. We had these 2-month deadlines, so I had to get back to it. And I just got ready for work and went down the street and then saw this. Basically, the whole road was flooded. So I just waded through all this flood water with water snakes and everything. Louisiana had crocodiles and water snakes everywhere around that lake. All the way to the house, took another shower at the house and got back to work. We're so excited making games 24/7 that even this flood wasn't going to stop anything. Also, during this year, during 1991, of making these 12 games, we also moved the whole company from Louisiana to Wisconsin, up to Madison, Wisconsin. So that takes a lot of time out of game development. And we couldn't really afford to have things go wrong with our game, that would stop us or be showstoppers. So we came up with kind of another core principle that was really important for our team. Basically, it's incredibly important that your game can always be run by your team. Bulletproof your engine by providing defaults on load failure. So if you have 100 people sitting there developing a game that will not run, you're paying for 100 people to do nothing, waiting for it to get fixed. So that's a bad idea. So we recognized the importance of keeping the game always playable, and we decided to bulletproof our engine by making all inputs solid. Let me see if I can get this cursor over here. There's a cursor moving around somewhere. Oh, here we go. Okay, got it. So game engines typically fail because they're trying to load bad, corrupted, or non-existent data. Checking for this data and providing a default, if there's a failure case, will keep the game running and quickly show you what is missing in the game. So if you can't load, say, a sprite, just show a bagel, right? If the theme song's not loading, play Batman or something. You know, just play something obviously wrong for the game. Missing sound effect, something super annoying. So that was super important for us. So the whole team was basically running the game at all times without crashes. So after 1991, id Software's first stage of company development was complete, and another important principle was in effect that we had decided on, which was to keep your code absolutely simple. Keep looking at your functions and figure out how you can make them even simpler. So we wrote all of our games up to and including Quake in pure C, not C++. So stage 2 is about to begin. In August of 1991, we decided to move to Madison, Wisconsin. Tom Hall and I visited in August at the time, found it to be really, really nice. You know, Tom used to live there when he went to college. He graduated from, University of Wisconsin-Madison. So we moved all 4 of us up there, and we continued working on our games. Only 4 months later, we were found dead in the snow, victims of Wisconsin's brutal winters that we did not research. So, moral of the story, do research. We knew how to program an assembly language, but not how to ask Tom Hall, hey, like, what's winter up here like? So after 6 months of that, we moved down to Texas. Nice and warm there. So, also, we had a new principle that was really important. Great tools help make great games. So spend as much time as you can on tools as possible. I wrote a tile editor in 1991 named TED, tile editor. TED was used for 33 shipped retail games, several of which were even 3D games like Hover Tank 1, Catacomb 3D, Wolfenstein 3D, Spear of Destiny, Rise of the Triad, Order 7, and others. Shadowcaster. So basically it was January of 1992. We decided to go all 3D based on the Catacombs 3D promise. It was really, really great. It looked cool, but Catacombs just didn't play really cool. Like shooting fireballs out of your hand there. It's not cool. Wolfenstein 3D took 4 months of development time, basically to get to the shareware launch, with 1 episode of levels. Took 2 more months to finish all 6 episodes of levels and the hint book. And the first month it sold 4,000 copies, all priced at $60 each. So that was better than what we had done before. Spear of Destiny took 2 months. It's a prequel to Wolfenstein 3D, and it was retail only. Soon after that, Tom Hall traveled to Kentucky to work for a couple months on Wolfenstein VR. Yes, it was 1992 VR. Not like today's VR. Back in the days of Commander Keen, I discovered a small 3-person game company called Raven Software up in Madison, Wisconsin. I just called them up, went over to their place, introduced ourselves. Flash forward about 7 months later, and we did a little work with them by modifying the Wolfenstein 3D engine and licensing it to them for a game called Shadowcaster. So Shadowcaster's tech improvements were sloping floors, lighting, and fog. This engine looked slightly better than Wolfenstein 3D, but it wasn't good enough for our next game. So John Carmack spent some months thinking about how more advanced the new engine could be. Well, it really should be for the next game that we decided to call Doom. So based on the rapid development of our previous games, we came up with another important principle. So we're our own best testing team, and we should never allow anyone else to experience bugs or see the game crash. Don't waste other people's time. Test thoroughly before checking in your code. Don't have the mindset of throwing it over the fence for testers to find. Put a bug in a database and then you get to fix it later. It's a really wasteful cycle. We did not have any beta testers in id Software until after I left, so all those games are just debugged by programmers. After 1992, id Software's second stage of company development was complete, along with another principle, which is as soon as you see a bug, fix it. Anybody believe in that? Yeah. don't continue on. If you don't fix your bugs, your new code will be built on top of bad bugs. And then it will ensure an unstable foundation. So if you check in buggy code, someone's gonna be writing code based on your bad code, and you can just imagine how that goes. Bad time. So the ideas from Doom came from our D&D campaign, which was full of demons. We also love the movies Evil Dead and Aliens. So Doom's design was kind of a mashup of ideas. At the beginning of Doom's development, we created a new core principle. We did something different at the beginning of Doom's development. This was to use a development system that is superior to your target to develop your game. So before Doom, we were making games for DOS while developing on DOS, just like everybody else did. But we thought that we could do better if we used more powerful computers and a more advanced operating system to develop our games. So we developed Doom on Next Step workstations. They were far superior to DOS. Next Step eventually turned into OS X, or OS X. This also meant that one of our core principles was upheld, which is great tools help make great games. We could make far better tools on Next Step. DoomEd and QuakeEd were two of the most important tools that we had on that platform. They both really helped us create levels fast and test them very quickly. So you might not have known this, but we had 5 people on our team creating Doom. After Tom Hall left, we hired Sandy Pearson, David Taylor, which brought us all the way up to 6 people. So unbelievably, while making Doom, we had to stop all production, and we had to create the Super Nintendo port of Wolfenstein 3D as fast as possible. So because we were starting from never having programmed a Super Nintendo, it took us 3 weeks because we had to learn the hardware. Then we jumped back into making Doom again. We uploaded the shareware version of Doom to the University of Wisconsin server on December 10th of 1993. The excitement for the game was unprecedented. People were actually sitting on the server creating files in the upload directory that were sentences like when.will.we.c.doom. We got random phone calls in the office asking when it would be out. Somehow people knew this game was coming out soon. So time for another quick story. During the final day of Doom's creation, we worked 30 hours. Yeah. We had the game running on all computers in the office to ensure that it was solid. However, on a couple computers, the game just froze up. The menu could be brought up, but the gameplay just totally stopped. John Carmack thought about what could possibly be happening, and he figured out the solution without having to do any debugging. He was correct in his solution, and we finally uploaded the game after this 5-minute fix and a bunch more testing. So at the beginning of 1994, I started working with Raven Software and developed Heretic using the Doom engine. Anyone remember that? Heretic. All right. I wanted to see how an inventory system in a medieval version of Doom would play. It turned out pretty great. We also made Doom 2 in 1994, over 8 months, and it was released on October 10th, 1994. In addition to this, we did the Jaguar port of Doom ourselves in-house. Again, we were multitasking and we were making multiple games, 2 games in 1993 and 3 games in 1994. In 1995, we started working on Quake. We had 9 developers at that time. 4 designers, 3 coders, 2 artists, and I was the only one to do both coding and design. So I wrote QuakeEd and experimented with level design in full 3D. Again, we started with a clean code base, so no code from Doom was used in Quake, which was another of our principles of development. Write your code for this game only, not for some future game. You're going to be writing new code later because you'll be smarter. Also, you're not tying yourself down to limitations of your past code, so get used to inventing new things. The Quake's engine was being developed by John Carmack, and the rasterization was by Michael Abrash. John's on the left and Mike's on the right. John Cash worked on the network code, which was really important. He went on to become the lead programmer of World of Warcraft. Quick story. So this relates back to our belief that developing in a superior operating system can result in a better game. So while making Quake, we had made a deal with Cray Supercomputers to buy a Cray 6400 super server for half price. Our plan was to have our whole development team connected to it, to BSP and lighter maps, as well as crunch whatever new kinds of data that we would come up with for our next game's engine. So the computer room in Quake's DM3 level was going to be full of Cray computers as a reference to this new hardware that we were going to acquire. Unfortunately, Cray was bought by Silicon Graphics just before Quake was done, and the deal fell apart. So this computer room in Quake is filled with the usual rectangular mainframes instead of the C-shaped Cray computers. So after publishing Heretic, I started working with Raven on Hexen. Anybody play Hexen?
Yeah.
All right. Yeah. I wanted to see how an FPS would play with a HUD level system and character classes. So Hexen launched on October 30th of 1995 during the Deathmatch 95 event that was happening at Microsoft in Redmond. A month later, I got Raven started on my next game design, which was called Hexen. It would be the third game in the series, Heretic, Hexen, and Hexen. Although Hexen was never finished, it turned into Hexen 2, but it wasn't the same game design. And that happened because I left it. During this time, in 1995, we noticed a small game company making some kind of cool games, like Raptor, Call of the Shadows, if anyone remembers that. We brought this company down from Illinois to make a game that we would publish. They would develop it and we would publish it. They called themselves Rogue Entertainment. And about 14 months after bringing them down, we released Strife, which used the Doom engine. So Strife was an FPS RPG, and it was really, really fun. There's a Strife Veteran Edition out on Steam right now. Back in 1996, it showed that combining genres could actually make a fun FPS. Nowadays, we have Destiny and other FPS RPGs, but Strife came first before all of them. Also, during 1995, we made the Ultimate Doom, which was a retail version of the full version of Doom with an extra episode in it. And we made the master levels of Doom, which was 21 custom levels for Doom 2. So id Software was still 9 developers in size, and we released 2 games in 1995 while we were working on Quake. So work continued on Quake, and 14 months after starting, we released Q-Test on February 24th of 1996 for the world to test our internet gameplay. So during the next 4 months, we worked very hard to complete Quake. We also released Final Doom, which was created by Team TNT and the Gazillion brothers, and an add-on for Hexen called Death Kings of the Dark Citadel. So one important principle that helped us to get Quake done faster was this one. Encapsulate functionality to ensure design consistency. I know it sounds like a mouthful there. So examples of this in Quake would be like the torches on the wall. We could have made the level designers place a torch model and then a fire model then animated, and then a torch sound entity all in the same location, but then if we needed to move a lot of stuff around, something could have gotten left behind. It's far easier to just create a torch entity that had all the functionality built into it. Also, water in the game needed sound effect entities all over the place to fully cover the surface of the water, so you would hear the water everywhere. But if the water got modified in the level, moving all those entities around and deleting some would have been a huge mess. It was just far easier to make the game just play water sounds when water was being rendered on the screen. So it's a renderer level feature, and it was out of the designer's hands, so it always worked. So it ensured consistency and it saved memory. So we did the same thing for the Sky Audio in Quake. So I released Quake on a Saturday, shareware, on June 22nd at 5:30 Texas time on the University of Madison's site. So quick story. So while Michael Abrash was programming the renderer for Quake, he was interleaving CPU instructions with FPU instructions, is all in assembly language, to calculate perspective correct texture mapping. And sometimes while he was playing the game, just for one frame, it's running at like 60 frames a second, but for one frame, the game would show a completely different part of the map. So he isolated the only instruction where that could possibly happen in his renderer, and he determined that it was just impossible for it to be an invalid value. The value was turning out to be 0, but there's no way that it could actually have been a 0. So he had a friend from Intel come over and go through his analysis, and his friend agreed with him. Yes, that's impossible. His friend told him that there was a known error with the floating point divide instruction on the Pentium that was overclocked. So it was a hardware error. So there's nothing we could do, so we just left it alone. This bug is known as the Pentium FDiv bug, which you can look up on Wikipedia. So, Quake is the game that introduced the world to mouse look in a 3D game, high-speed true 3D world, and internet multiplayer. So clans sprung up immediately, as did esports, and tournaments started happening all over the place. And Quake World launched 5 months later in 1996. So making games was and still is our life. Like, we love it more than anything else, as you can tell by our release of 28 games in 5.5 years by less than 10 people. Many other games were released that used our licensed technology over the years, and here are some more core principles that we learned from all of this work. So try to code transparently. Tell your lead and your peers exactly how you're going to solve your current task and get feedback and advice. Don't treat game programming like each coder is a black box. Like, a project could just go off the rails and cause delays, especially if someone's a junior and they don't really understand all the algorithms that are out there, or that there's other functions in the code base that they could use instead of writing another duplicate of something that exists already. Programming is a creative art form based in logic. Every programmer is different and will code differently. Don't waste time focusing on a rigid coding style. It's the output that matters. So we keep working, make great games. It's in our blood as it's in your blood, which is why we're here at ECGC. So you want to be the best, go be the best. And thank you for inviting me here to ECGC, and I will answer questions now. Thanks.